Hi, my name is Francisco Rius. I am the head of data science and data engineering over at Mojang Studios. And today we're going to talk a little bit about our data journey over the past number of years. Before we kick off, I want to tell you a little bit about myself. Again, I'm Francisco. I manage the data engineering and data science teams over at Mojang Studios. Mojang Studios are owned by Microsoft. We're part of Xbox Game Studios, and we are the makers of Minecraft. Before I joined Mojang, I worked at Electronic Arts. I was the director of analytics for several sports titles, including FIFA, NHL, and UFC. And I've been an analyst and a data scientist and managing data science teams for the vast majority of my professional careers. So now I want to talk a little bit about Minecraft. What is Minecraft? Well, Minecraft is the original sandbox open world video game. What does that mean? Well, this is a video game where players don't really have a beginning or an end to their experience. It is an open world. What that means is that there are endless possibilities on what players can experience. They can go out on quests, they can engage with their friends, they can explore worlds, fight a mob, you name it. We operate Minecraft in 22 different endpoints. Players are able to engage with Minecraft on a PC, on a computer. They can go on their mobile phones, for example. They can go on console. And nowadays, they can also engage in some of our properties like Minecraft Dungeons. They can also use Microsoft xCloud or Xbox xCloud to engage on the cloud. So basically, we're operating Minecraft anywhere where a player wants to engage in video games. When you think about data function that is tasked with normalizing data from 22 different endpoints, you can think about the task at hand. Also, Minecraft is massive. We see upwards of 110, 120 million monthly active users. It is a very highly diverse and global audience. Funny anecdote, when we actually have done geolocation studies in the past, we've actually seen activity happen in places as remote as Antarctica. And what's really, really cool is that tells us that there's someone out there doing research, or a group of people when they're doing research and during their downtime, they're actually playing Minecraft. We see activity in the Vatican. We see activity in every single corner of the world. We also see a lot of diversity in our audience. We see different play styles, different types of activities happening in the game, networks of friends, so on and so forth. And last but not least, depending who you ask, Minecraft may be the best-selling game of all time, right up there with Tetris. So now I want to talk a little bit more about the context in which data science and analytics operate in Minecraft. Our context. And we see ourselves as operating in the intersection of art and science. If you think about video games, they are a technology product. There's a lot of science behind video games. So for example, there's people building a game engine. There's a lot of technology, computer science behind it. There is a need to scale globally, obviously, to accept and to be able to maintain connections with hundreds of millions of players all around the world, either on Wi-Fi or on cell phone signals, so on and so forth. So there's the science aspect, the technology aspect of video games, but there's also the art component. The video games in nature are very creative. And you can see just the background on your screen. It's how beautiful Minecraft is, and there's a lot of art behind it. And we also believe that there's that analytics and data science teams operate in that intersection of art and science. A big part of our function is also to talk a little bit about the art part of our video games. So now I'm going to tell you a little bit of a story. When I was growing up in Mexico City, this is back in the 80s, I had an uncle who loved astronomy. He was a physicist, and he was very interested in the stars and looking at the stars, at the universe. But he had a really archaic telescope. And I remember that he would let me look at his telescope up in the sky. And the experience wasn't very good. All I could see was just like, a handful of stars, maybe a little bit of zoom in. And we would look at the moon and didn't really see a lot of patterns. But then after a few years, he saved up some money and he ended up buying a better telescope, or technology advanced, and he just ended up being able to get a better telescope. And I remember that completely changed my perspective of the universe and looking at the universe. So now, taking that analogy a little bit further, what you have on your screen right now is a player network in a video game. And what does that look like? It really looks a little bit more like a very chaotic universe. You see a lot of stars. You see different colors. For those of you who are familiar with player networks, you see that creating a player network study is very compute intensive. It requires a lot of processing power. The data structures that are needed are fairly heavy. And being able to get to a meaningful visualization of player network requires quite of a heavy lift on the compute side. But when you we're visualizing the player network in one of our video games. This is actually a subset of random sampling of 0.0004% of our player base, and you can see that even though it looks somewhat chaotic, there's a lot of order in chaos. And what can you see from a network study? You can see that the edges, the big circles, actually give you some meaningful information about potential center of gravity. For example, a color could mean a geography, or it could tell you something else about the way that players engage with each other. For example, a play style, whether players are engaging with each other in combat or in creative modes, you name it. So there's a lot of information that we can infer just by looking at player network study. And this is a capability that we recently acquired. It's been 3 years in the making. We're able to understand how players interact with each other in a video game by scaling up and improving our tech stack. And that has been a journey that has been going on for the past 3 years or so. So I'm going to jump into and tell you a little bit about our technology journey from a data science and analytics and data engineering standpoint since around 2019. So now I'm going to tell you a little bit more about how our data ecosystem felt like in 2019. You have a snapshot in your screen, and this is basically just a sketch, right? You probably cannot differentiate. You cannot really see what this shape is going to start looking like. Maybe there's a house, there's a little bit of an idea coalescing, and that's very much an analogy to what the world felt like for our data science team back in 2019. We knew where we're headed, we knew what we wanted to do, but it was basically in plans. We were sketching out the future. So fast forward 4 years later, and now we have what we believe is a beautiful functional house with all sorts of bells and whistles. You can see in your screen that there's a lot of activity happening. You have Minecraft Alex and Minecraft and Steve, both doing different things. Minecraft Alex is still building, but meanwhile, Minecraft Steve is fishing and maybe collecting some resources. And you can see at the top of the screen where we have a nether portal where this house is actually connected to a completely different dimension. And this is an analogy to the way that our data ecosystem feels today. And it's a happy place, but also a very high functioning and functional place. So now I'm going to go back and give you a little bit more detail around some of the pain points that we were experiencing back in 2019. And also talk a little bit about how we resolve some of those pain points. So back in 2019, we had a very limited view of players. What does that mean? Well, we were collecting data and we had good data infrastructure at point of ingestion. But the data was landing and we couldn't do much with it because there's so much volume of data landing that our analysts and data scientists were unable to actually parse it out and make meaningful observations about players on a time series basis. Maybe we were able to examine a few hours of data. Maybe we were trying to understand at a very, very high level whether our services were online. But from a behavioral standpoint, it was very difficult to really get a pulse on what was happening over time. So we had a fairly limited view of our player experience. There were also very low levels of collaboration, and it was really frustrating as a manager of the organization. our data scientists all had stood up different environments in their own PCs. So they all had a notebook client or some sort of, we were also using VMs, and they were sharing code using CSV files or just exchanging code using email, which is a very poor practice. So collaboration wasn't really enabled because our setup was fairly fragmented, and we relied on virtual machines at that point in time to do a lot of data science work. And last but not least, because our data was complex, we spent a lot of time batching data and writing SQL just to be able to maneuver on our data and being able to just handle the amount of data that we were capturing. So the data scientist experience wasn't great. They were probably spending 50-60% of their time writing SQL and batching data. They weren't able to allocate a lot of time to really creating insights and understanding how our players were experiencing Minecraft and working with the creative folks to make Minecraft better. So our ecosystem now feels very different, and our data scientists experience a completely different world. Our data ecosystem is player-centric. What does that mean? Where we can understand what our customers are doing over time on a time series basis. And that has really been enabled by technology. We are capturing a lot of data, but we're also able to run very sophisticated queries to understand whether players are engaging in certain parts of our ecosystem, but also whether they're engaging in different experiences across the ecosystem, and whether they're experiencing any sort of friction, so that we can make the game a little bit better and more engaging over time. Our technology is very flexible today. One of the biggest milestones that we achieved, and I'll talk a little bit more about this, is we were able to separate our compute versus storage. And that's a huge milestone, right? Because all of a sudden, our storage is somewhat agnostic to the compute layer, and we're using Spark and Databricks to run most of the compute. But that gives us quite a bit of flexibility because it futures-proofing the ecosystem. And last but not least, because we're saving a ton of time, we're not spending as much time batching data and writing SQL anymore. We're able to focus on insights, predictions, and of course, nowadays we're spending time in artificial intelligence and machine learning. So now I'm going to talk a little bit more about what our data ecosystem looks like today. This is just a quick summary of the big components. This is how modularized our ecosystem is. One of the things that we were able to accomplish here is at the very bottom, you can see that our data environment is unified. And we were able to do this through a couple of different strategies. At the very, very top level, the data that we're ingesting, we're actually storing it in Azure Blob or Azure Data Lake today. It comes in and we end up storing in Parquet format. We use Delta tables, and that's really all being stored in the Blob ecosystem on Azure Data Lake. But one of our big strategies here is also cataloging the data. Today we're using Apache Hive. And that's simply because we needed some continuity versus our previous ecosystem. What does that do? Is we're using and we're only using a metastore, so we're using an Apache metastore. And what that means is that creates a reference, so that when data scientists and analysts want to access data, they actually feel like they're mining a data warehouse. In our metastore, it has become the single source of truth. That's how most of our data is accessed in our Databricks environment. And last but not least, again, our Databricks environment today is our endpoint for data consumption. A lot of work happens in our Databricks environments today. Everything from the analysis of data, and I'll talk a little bit more about this, to actually building models, doing AI and ML. So now I'm going to talk a little bit about our success measures here. What we saw happen after we transitioned our data ecosystem into a new setup, and in large part in our transition to Azure Databricks, was that we ended up spending a lot less time in building data sets. And that ended up giving us about a 66% reduction in the time that we were spending in just building data sets. That's a huge milestone. If I see myself as a data scientist, if I'm able to spend just a lot less time in creating a data frame or a table, and actually I can spend the time either building visualizations or doing modeling, creating predictions, that's a huge win. It also helps me build my skill sets on more advanced applications. Another piece is because we're able to do recommendations at scale using this neat data environment, and I'll give you some examples on how that is happening. Our recommendations in the game are actually very effective. Content recommendations are 2.5 times more effective than human curated recommendations in the game. And that's because we're able to access machine learning models and AI models directly from our data environment today. Our data scientists are actually able to call very advanced applications just using simple commands in Databricks notebooks, and that's really exciting. We believe that we're saving money. Our team has grown, but our costs are not skyrocketing, and we believe that on a like-for-like basis, we see around a 20% cost reduction compared to our previous data setup. So we're pretty happy. And last but not least, and this is very important and sometimes overlooked, and I would say many times overlooked actually, we see a happier and healthier data science team for many reasons. I called out that they're spending less time on the heavy lifting of building data sets, but they're also able to focus on more advanced applications. And also the fact that they're collaborating, they're unified in a single source of truth, that actually goes a long way in helping our data scientists learn from each other. And that's a huge win for our team. So now I've just a visual representation of a loop that this is one of our biggest accomplishments over the past number of years as we have upgraded our tech stack. Our data scientists are able to access data and push recommendations, predictive models, treatments to the game directly from the single environment. So in the past, we felt like different data stores were very fragmented. The game was operating outside of the data ecosystem, and data scientists were operating in batch. So think about an example where a data scientist would produce a predictive model. They actually had to batch that the outputs of that model and upload them to a different game store. Nowadays, with our unification, we're actually able to orchestrate most of the prediction and ML through our Databricks environment. So I'm going to show you a few examples of how players are actually experiencing our tech stack today. So from a player experience standpoint, players can see recommendations. If you go into Minecraft, there's going to be 3 different buttons. There's going to be play, settings, and Minecraft Marketplace. Inside Minecraft Marketplace, this is where players can acquire different experiences. They can download worlds or skin packs to customize the character, so on and so forth. A lot of that content recommendations are curated by AI and machine learning algorithms that were developed by our data scientists. And players are going to see recommendations that are tailored to them. So in this example, what you have on your screen, you can see that there are 2 rows recommended for you and related items. Those are fully curated by machine learning models today. I want to just give a big shout out to our team. If you go to github.com/Microsoft/recommenders, there's about 45 different algorithms that are open source. Miguel, who is one of the lead data scientists in our team, who owns recommendation in our team, actually manages that repository, and a lot of our data scientists are very active in that repo. It was at one point or another the most popular AI ML repo at GitHub with 15,000 stars. So recommendation is still a very big topic in entertainment, in communications. So we're super proud of the work that our folks are doing in open source. And on the right-hand side of your screen, you actually have some examples of communications that are also being orchestrated through our data ecosystem and leverage prediction wherever possible. So for example, churn predictions are really important in gaming, just like they are in other areas of entertainment. And that is also orchestrated through our Databricks environment. So a few additional applications, use cases. This is a non-exhaustive list that I want to share with you. Product insights. A lot of work happens to try to understand what features in the game are successful and if players are encountering any points of friction, and how we can make the player experience a little bit better just to make it a little bit stickier and get our players to return and for them to be happy with Minecraft. Also, as you heard before, we're a very global game, so that means that a lot of languages are represented, and our data scientists don't speak all of the languages that are represented in our ecosystem and in the world of Minecraft. So we use artificial intelligence to help us with translation and try to contextualize what players are saying, either in social media or if they're, for example, raising support tickets. That's really important, contextualizing in language. Prediction and forecasting, this is a big area as well, as we talked about. Churn, trying to understand if players are encountering friction and they could potentially be churning out of the game. Bringing players back, if at all possible, through re-engagement strategies. And of course, segmentation is also really important. Trying to understand what are players doing in the game? Are there any commonalities? Are there any features that talk to specific segments in the game? And how can we make those better, more exciting, more fun? So what have we learned? I'm going to give you a few high-level thoughts, but we have learned a lot over the past number of years. The number one thing is really to look ahead. Future-proofing. One of the big things, a big accelerator for us was the fact that we were already planning on detaching our compute versus our store. And that has multiple advantages, but this is a strategy that has really paid dividends because it really allowed us to move into Databricks very quickly. Initially, we thought our POC into Databricks was actually going to take maybe 6 months or longer. And it actually was really fast POC. We had an environment stood up in a few weeks. And adoption was also fairly organic. That was very exciting for us because all we had to do was really stand up this environment. We were able to figure out connectors to our meta store. And that was actually fairly straightforward. We thought there was going to be a heavy lift there. So looking ahead, trying to future-proof the strategies and the decisions that you make today are going to obviously have a big consequence in the future. So look ahead, think of where technology is going, and think of strategies that could potentially impact the future. Harmonize. This is really important. So making sure that the technologies that we choose and that we invest on are can play nicely with each other. And luckily for us, most of our experience with Azure Databricks today is that it plays really nicely with all of the Azure components that we're using, like Blob and in the Azure Data Lake as well as other technologies, including our Hive Metastore, which is a little outdated at this point. Hopefully, over time, we explore Unity Catalog and other products. But choosing technologies that are going to play nicely with each other. I think in the world data science, there's a lot of technology that is emerging, a lot of different tools that are emerging, and it creates some risk for fragmentation. But it's also very important to not just think about the technologies that play nicely with each other, but also the role that data scientists and analysts are going to play in the ecosystem, in the environment. For us, having an environment that is low friction, where data scientists can share notebooks with each other, but also if we want to become more sophisticated, there's also integration with DevOps, with GitHub, repositories, so on and so forth, so that we can formalize and productionalize models, for example. And last but not least, expect a ton of iteration and continuous improvement. I've seen strategies in the past where there's a lot of planning and obviously a business is executing cycles. Our approach today is to think about an evergreen strategy where we're continuously iterating and improving, testing new features in our data ecosystem, understanding whether they're being adopted by the data scientists, whether they require training, and improving upon those. Really important to think about a continuum where we continue to improve over time and not very massive undertakings of transformation that could feel very disruptive. This is especially important in a world where our product is also evergreen, like Minecraft, where players are engaging 24/7, and any sort of upgrade, any sort of transformation has to happen gradually. With that, I am happy to engage in LinkedIn, or if you have any questions, please feel free to contact me. Thank you for taking the time, and really appreciate you paying attention to our use case. Thank you.